Hello students and friends. In this short video, you will find out the answer and explanation to question number 2 posted as part of the series of physics questions in my FB page, Watch and Learn. This is question number 2. A negative charge enters a uniform magnetic field that is directed into the reader. If the velocity of the charge is directed eastward, the magnetic force experienced by this charge is directed, letter A, north, letter B, south, letter C, into the reader, and letter D, away from the reader. So here's the illustration. We have here a negative charge that is moving with a velocity v directed towards eastward, right? It enters a region of a uniform magnetic field, capital B, whose direction is represented by these dots, which suggests that the magnetic field is directed into the reader. Okay, so we are asked to determine the direction of the magnetic force that the magnetic field exerts on the moving negative charge. So for our solution, we apply Fleming's left-hand slop rule. This is a technique that is based on the formula for determining the magnetic force F equals BQV, where F represents the magnetic force, capital B represents the magnetic field, which is assumed to be an external magnetic field, and small letter q represents the magnitude of the moving charge, and of course small letter v represents the velocity of the charge. Alright, so according to this left-hand slop rule, alright, you're going to position your left hand, alright, by having your thumb at an angle that is 90 degrees with the other fingers. Alright, so the four fingers are extended as well as the thumb. Here, the thumb represents, alright, it represents the direction of the velocity of the charge. Alright, or it may also represent the direction of the current. Alright, the four fingers extended represents, alright, the external magnetic field, or the direction of the external magnetic field. And the magnetic force F will be represented, or is represented, by the palm. It is called a left-hand slop rule because If you're going to use it to slap somebody, all right, the direction of your action to slap is such that the palm is directed out of the page in this illustration, right? So again, use this whenever the moving charge is a negative charge, which is what's given in the question. Supposing the moving charge is a positive charge, then we make use of the Fleming's right hand slap rule. But for now, this is what we are going to use. So our given data or quantities are, we have the velocity of the negative charge directed eastward, right? So get ready your left hand, position it in such a way that the velocity v is directed eastward or to your right. Okay, if you put your left hand in front of you, all right, make sure that your thumb is pointing towards your right, or it's described here as eastward. Now, for the external magnetic field, capital B, which is represented by your other four fingers extended, it says here that the direction of the magnetic field is into the reader. All right? Into the reader, that means you can imagine the magnetic field vector or vector arrow that is directed towards you perpendicular to the screen or to the paper. All right? Into the reader, in other words, towards you being the reader. All right. So, you have to make sure that your other four fingers are directed towards you into the reader. And then, do the action of slapping. So, when you slap, using your left hand, all right, the direction of your palm will represent the direction, the magnetic force exerted by the magnetic field on the moving negative charge, right? And that will be, the force is directed north if you're to follow the geographic direction earlier illustrated in the diagram. Force is directed northward or towards north. Our final answer, therefore, to question number 2 is that the magnetic force experienced by the charge is directed north. Option letter A. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.